Processes for the production and distribution of poisons for use in war. Due to the nature of war and conflict, the use of toxic chemicals has unfortunately been a common practice throughout history. Toxic chemicals have been used in various ways, from poisoning water supplies to using them as weapons of mass destruction. In this article, we will examine the production and distribution processes of toxic chemicals used in warfare. Production of toxic chemicals for warfare typically involves the synthesis of chemicals that can be used as weapons to cause harm or death to people, animals, or plants. Some of the most commonly used toxic chemicals in warfare include nerve agents such as sarin and VX, blister agents such as mustard gas, and blood agents such as hydrogen cyanide. The production of these toxic chemicals is typically carried out in specialized facilities, which are designed to handle hazardous materials and ensure the safety of workers and the surrounding environment. The production process typically involves the synthesis of the toxic chemicals from precursor materials, which are then purified and stored in specialized containers. The production of toxic chemicals for warfare is typically carried out by governments or military organizations, and is often shrouded in secrecy. The use of these chemicals is regulated by international treaties and agreements, such as the Chemical Weapons Convention, which prohibits the production, stockpiling, and use of chemical weapons. However, despite these regulations, the production and use of toxic chemicals for warfare continues to be a concern, particularly in regions of conflict where governments and military organizations may not adhere to international norms. The distribution of toxic chemicals for warfare typically involves the transport of the chemicals from production facilities to storage locations or deployment sites. The transport of these chemicals is typically carried out in specialized containers, which are designed to prevent leaks or spills that could pose a hazard to people or the environment. The distribution of toxic chemicals for warfare is also subject to regulations and international agreements, which require the safe and secure transport of hazardous materials. However, the transport of these chemicals can also be a target for sabotage or attack by opposing forces, which can pose a significant risk to the safety of people and the environment. The use of toxic chemicals in warfare has significant humanitarian and environmental impacts. The use of these chemicals can cause immediate harm or death to people and animals, as well as long-term health effects and environmental damage. The use of toxic chemicals in warfare is also subject to international law and humanitarian norms, including the prohibition of the use of chemical weapons. The use of these chemicals is considered a war crime, and those who use them can be held accountable under international law. In recent years, there have been efforts to prevent the production and use of toxic chemicals in warfare, including the destruction of stockpiles of chemical weapons and the promotion of disarmament and nonproliferation. However, the continued use of these chemicals in regions of conflict highlights the challenges in enforcing international norms and preventing the use of chemical weapons. One of the challenges in preventing the production and use of toxic chemicals for warfare is the difficulty in detecting and identifying these chemicals. Toxic chemicals can be easily concealed and transported, making it challenging to detect their production or use. To address this challenge, various methods for detecting and identifying toxic chemicals have been developed. One of the most commonly used methods is gas chromatography mass spectrometry, GCMS, which can be used to identify and quantify the components of complex mixtures, including toxic chemicals. Other methods for detecting and identifying toxic chemicals include infrared spectroscopy, Raman spectroscopy, and immunoassays. These methods can be used to detect and identify toxic chemicals in various matrices, such as air, water, soil, and biological samples. In addition to detection methods, efforts have also been made to promote transparency and accountability